Okay, we're going to talk about domain and range, key attributes of quadratic functions, and we're going to focus on using our calculator to help us find all of this information so that we can save time and save effort. So if they give you an equation, remember f of x is another way to say y, so we're going to go to y equals and we're going to type in our equation, x squared plus 2x minus 3. And what we're going to do is we're going to graph it, make sure we need to adjust our window, and I can see my vertex, my roots, my zeros, my solutions, my x-intercepts all very clearly, and my y-intercepts. So now I'm just going to start finding. For everything, second trace, and then you're just going to pick options off the menu. For our y-intercept, we're just going to pick 1. And remember, we have to type in 0 for our y-intercept, and it is at 0, -3. Now I'm going to find my x-intercepts, which are my roots or my zeros. So I'm going to second trace, and I'm going to select 2. And now what I have to do is, since there are 2 of them, I have to find them one at a time. So I'm going to find the one on the right first since I'm closest to it. So you either move left or right, and I'm going to move right, and I'm going to move my cursor right to my x-intercept. Then I'm going to move left 2 and lock in. Go back to my x-intercept, and now I'm going to go to the right 2 times and hit enter to lock in, and then I'm going to hit enter again to guess. And my first 0 is at 1, 0, or you can think about it as x equals 1. All right, now I'm going to do second trace 2, and now I have to move that cursor all the way around my parabola to my other x-intercept. So I'm going to get it as close as I can. I think that's closer, and now I'm going to go left twice, enter, go back to my x-intercept, now I'm going to go right, enter. Hit enter again, and my other intercept is at -3, 0, or x equals -3. And now I'm going to find my vertex point. So second trace. Now I have to pick option 3 or 4. Since my parabola opens up, my vertex is going to be a minimum value. Okay, so I'm going to select 3. And I have to move my cursor to as close to my vertex point as I can, and then it's asking me to go to the left. So I'm going to go left, enter, back to my vertex, and now I'm going to go to the right twice and hit enter, and then hit enter again to guess. And my minimum as my vertex is at the point -1, -4. Since it's asking me for a max or min value, that is always the y value, okay, of your vertex. And so my y value, my vertex is -4. That is the lowest that my value that my graph can have. And axis of symmetry, that's where it cuts it in half, and it's always x equals, and it's always the x coordinate of your vertex. So we're just going to write that. Now we're going to look at our domain and range. Since I don't know what I'm counting or measuring, my domain is going to be all real numbers. Okay? Because I don't know how far left and how far right I'm supposed to go, and I don't know what numbers I'm using because I don't know what I'm counting. And so that's why it's all real numbers. So range, we're going to look at the lowest that it goes on the y-axis. Well, that would be my minimum value. So it starts at -4 and it goes up from there. So y is greater than or equal to -4. All right, for this graph, we don't have an equation, so everything that we find is going to be off the graph. So the first thing I'm going to do is look at my y-intercept, and it crosses the y-axis at 1, so that would be the point 0, 1. And my x-intercepts, the only place it crosses the x-axis at is 4, so that would be 4, 0. Or you could think of it as x equals 4. My vertex is at the top, so it's going to be a maximum value, and that ordered pair is 2, 5. And from my vertex, I can get my max value, so it's the highest y value, and that would be 5. And my axis of symmetry is a Vux line, so it's got to be x equals, and it's going to cut right down through the middle of the parabola and cross at 2. It's also the x value of your vertex. Now for domain and range, we're going to draw boundary lines. So for my domain, I'm going to go left to right, and for here it's x is greater than 0, and I'm going to use greater than because there's an open circle. And for this right side, right boundary line, it's x is less than or equal to 4 because it's a closed circle, closed line, so solid line, so I need a solid line in my inequality symbol. So now I'm going to say 0 is less than or equal to x is less than or equal to 4. Remember, if you have two boundaries, that first boundary you have to switch the order of your x and your value, and then you also have to flip your sign. And now for my range. So I'm going to go the lowest on the y-axis I can go. Most people are going to say 1, but you actually go lower. You go here. So y is greater than or equal to 0. And now I'm going to draw my high boundary here. And since it's a solid line, I need a solid line with my less than symbol, and that would be 5. So remember, we're going to switch the order of the lowest. So it's going to be 0, and then y, and then we're going to flip our signs. So it's going to be less than or equal to, and then less than or equal to 5. Okay, now we're going to look at a word problem. So the height of a soccer ball kicked into the air can be modeled by y equals negative 16x squared plus 48. So we can actually type this into our calculator. And we also have a picture here, so we could also get information off of here if we wanted to. But I'm going to practice in my calculator because that's what I want you guys to do. So I'm going to go ahead and hit graph. I'm going to have to zoom out. And I'm going to go ahead and adjust my window to how they have it set up. They are counting by 5s for the y scale, and they're going up to 45 and 0. And then for their x's, it looks like they're counting by halves, 0.5. And they go out to 3.5. And I'm just going to leave negative 0.5. I'm actually going to go for my y min. I'm going to go out to negative 5. That way I have a little bit of gap between the edge of my window and my axes. Okay, so now I'm going to find the y-intercept. Second trace 1, type in 0. My y-intercept is at the origin. So what does this tell me? This tells me that the initial height of the soccer ball is 0 feet. So it's starting on the ground, okay? You could also say that. The soccer ball starts at the ground. Is kicked from the ground, something like that. Okay, second trace 2, we're going to find our x-intercepts. So I know that one of them is at the origin, okay? But I'm going to find this one over here on this side of my parabola. So I'm going to have to hold my right arrow down and let that cursor move around the other side of the parabola. And remember, you want to start off at the x-intercept, then go left. Go left. Now I'm going to go back to my x-intercept. Now I'm going to get lock into the right, and it may disappear off the screen. That's okay. And the other one is at 3, 0. So it tells me that the soccer ball is in the air for 3 seconds. You could also think of it as it takes 3 seconds for the soccer ball to come back to the ground. Okay. All right, maximum value, minimum values, that means vertex. So since we are opening downward, we're going to have a maximum. So second trace, we're going to pick option 4. And now I'm going to move my parabola back to my vertex point, or as close to where I think it is as possible. Okay, so I think that's pretty close. Now I'm going to go left a couple times, enter. I'm going to go back to my vertex, and now I have to go to the right side of my vertex. I want to make sure when I lock in, I'm on the right side of my vertex point so that my vertex is in the middle, and it says 1.5. So my vertex value is at 1.5, 36. And it's asking for the max value, so 36. And since 36 is a y value, it's saying that the soccer ball reaches a height of 36 feet. And if we wanted to know how many seconds it takes it to reach 32 feet, we just look at the x value of our vertex. It takes 1.5 seconds for it to get 36 feet. All right, axis of symmetry, that is the x value of our vertex, which is why I found the vertex point. So it's at x equals 1.5. That's that imaginary line that cuts our parabola in half. Oh, and here's a spot for our vertex, 1.5, 36. All right, that is how you find domain and range and attributes of a quadratic using your calculator.